Hi, this video introduces you a couple of statistical techniques that are used to quantify the relationships between or among variables. Often we expect certain tendencies between variables and need to define the relationship quantitatively. For the following 2 weeks, we are going to learn about several statistical techniques that are used to examine the relationships between or among variables and quantify that. The tools are grouped into 3 categories. The first one is correlation analysis. In Korean, it is called 상관관계 분석. Often, students mistake correlation for relationship. Also, in Korean language, students often mistake 상관관계 for 관계. Relationship simply refers to any relation between or among the variables. However, the correlation indicates the correlation analysis. Unless you really intend to mention the correlation analysis, you better be careful not to misuse the term correlation. In correlation analysis, the Pearson correlation analysis is the most typical technique. A non-parametric alternative for this is Spearman correlation analysis. In addition, when we need to estimate the relationship between more than 2 variables, we can use the Kendall's W test. This test provides a less accurate data, but it is quite useful to catch a big trend. In design study, the Kendall's W test is quite practical. The second category is the regression analysis. In Korean, it is 회귀 분석. Perhaps you have heard about the regression analysis from somewhere because it is one of the frequently used statistics across different disciplines, including marketing and design studies, of course. In correlation analysis, the relationship between variables are examined, but there is no cause nor effect. However, for regression analysis, you assign the role. When there is one cause and one effect, a simple regression analysis can be performed. Because the relationship is quantified, both cause and effect should be measured in a continuous scale. The multiple regression analysis, in Korean, 다중회귀 분석, this is used when you have more than one cause. Through a multiple regression analysis, you can draw an equation or you can extract an equation that quantifies the relationships between many causations and one effect. Lastly, it is about the conjoint analysis. Often, the independent variables are measured in nominal scale, such as gender or cultural groups. The conjoint analysis is used to investigate a joint effect of a certain combination among variables. Let's learn more about them one by one. When we eat more donuts, of course, in addition to the regular meals, it is pretty much predictable that we are going to gain some weight. But you feel more appetitive when you have gained some weight recently. At least in my case, so when I feel more appetitive than before, then I can be sure that I have gained some weight. I think many of you have a similar experience. Therefore, depending on your research topic, in fact, any of two can be either an independent variable or dependent variable. In other words, one of two can be a cause or can be a result. In correlation analysis, we are examining the direction and the size of the relation between variables. And there is no causation nor effect yet. The correlation analysis provides you the direction and size of the relationship. Direction means whether the increase or decrease occurs together or in an opposite way. The increase of a donut occurs together with the increase of weight, or vice versa. As another example, when you study more, your grade will be higher. So the relationship between study hours and exam score is or has a positive relationship. The size of a relationship means how powerful the relationship is. Basically, it is the concept of effect size. The effect size is that we learned in the t-test and also ANOVA test. Of course, the way to calculate the effect size for correlation analysis is different from the previous tests. Okay, once you have checked that there exists a correlation between two variables such as donut and gained weight, you can go further toward the regression analysis. The following two scenarios sound plausible, and let me choose the first one. From the correlation analysis, you might have found that there is a positive correlation between the donut intake and gained weight. Based on the data about the donut intake and gained weight, we can develop an equation. For example, you gain 500 gram per week if you eat 2 donuts every day. Based on this record, you can quantify the relationship. For example, when you eat 4 donuts every day, then you can predict that you will gain 1 kilogram per week then. Because we have one cause here, this is called also as simple regression analysis. The multiple regression analysis includes more than one cause. Imagine you develop an equation that can predict your gained weight based on your donut intake, fitness duration, and water drink. When you have enough number of data regarding these 4 variables, you can extract an equation by performing the multiple regression analysis. In many of the scientific papers, the equation as such is the product of the study because the equation is a tool to identify the existing phenomena as well as to predict a potential phenomena. Then lastly, the conjoint analysis. Conjoint analysis is a kind of a loose technique of multiple regression analysis, but it is very practical, particularly when the independent variables are measured in nominal scale. Perhaps in design study, we need to find a big picture rather than identifying the size of a coefficient more accurately. The conjoint analysis is a kind of rough test, but ironically, therefore it is useful for design research. Moreover, if the multiple regression analysis is focusing on the extraction of equation, the conjoint analysis provides an order of effect of joint combination on the dependent variable. Well, I hope this video has challenged you to learn more about the new statistical techniques that quantify the relationships between variables.